Let's see, what is new at Hacker News? Okay, this could be interesting. This actually looks interesting. How I found a bug in Intel Skylake processors. That could be pretty good. E-bikes not slowing down. Time travel. Major design. Oh, Johnny Ive. He went to, I think, Ferrari or Porsche or something. That could be interesting, actually. Teens recruited. Yeah, none of these really actually look that interesting right now. I gotta say, today it's kind of a slow day on news. Terminal. If you guys see anything here that you guys want me to read, I'll be happy to pull it up. But right now, oh, okay, wait, this looks interesting. Robinhood announces data security incident. Let's add that to the list. Pinterest ruined photo search on the internet. Die. Yeah. Let's actually, how to get the most prestigious startup accelerator in the world. Justin Kahn. Okay, so there's probably some tweet. Avoid surprise bills. A quantum walk down Wall Street. Okay, that's pretty interesting. Okay, so let's actually see what Robinhood actually fucked up this time. You know, infinite money glitch notwithstanding. Okay, let's see. Late evening, November 3rd, did a security incident. Unauthorized third party obtained access to a limited amount of personal information of customers. No social security numbers, bank accounts, or debit cards were exposed. No financial loss. All right. Social engineer. Okay, so they social engineer customer support employee by phone and obtained access to certain customer support systems. All right. At the time, we understand that the unauthorized party obtained a list of email addresses for 5 million people, and a full name of 2 million. Okay, so it just got a bunch of lists of customers. All right. And then for some of them, name, date of birth, zip code was exposed. Oh, okay, so your personal information was out there. And yeah, so basically, they were able to access personal details of a person. Okay. As safety first, we owe it to our customers to be transparent and act with integrity. Blah blah blah, blah blah blah, and blah blah blah. Okay, so this is not really much of anything. I think incidents like these happen all the time, and they disclose it, but I don't think it's anything worth like gushing over. Actually, let's see what else is here. A quantum walk down Wall Street. Oh, I have to pay for this shit. Fuck it. Johnny's Ive major for design since leaving Apple isn't what you'd expect. Honestly, like, design is one of the things that I think people don't really give a lot of credit to designers for. And there's a lot that people can actually learn from design. Let me give an example. Like, form follows function, right? And so when you're designing something, you need to keep in mind like a bunch of different like aesthetics, designs, and functions in place for this. So a good example would be like, let's say your phone, right? What shape should a phone be? To us right now, it's very obvious. You know, it should look something like this, which is like a square with a screen. You know, but who says it can't be like a circle? Who says it can't be, the fingerprint should be in the glass? You know, like on touchscreen, or and why does the camera have to be in the back and front? You know, it's all these little design decisions that make things kind of interesting for a designer, and of course, like having context on that, having actually seen what an actual product looks like, it's very easy for us to say, oh yeah, this is exactly what a phone should look like. But consider that like, well, maybe let's take like icons for example. What shape should an icon take? What theme should it have? And this is something that Apple really grappled with when it first released the first iPhone, right? You remember those little icons, those widgets, where it looked like raised, curved, almost 3D like. And then you remember like the old Instagram. Actually, let's pull it up. Instagram old logo. Let's actually look at this. See, you see here how it's like very very realistic, right? Who would have thought that this should be the icon? I mean, nowadays we're more into like the sleek 2D minimalist style, and Apple really led the way. But how do you make the decision to really create that aesthetic? That's one form of design. Another thing is just like the design of your car. Who says the shape of the car should be XYZ? And really being able to balance all these factors is not unlike what a major engineer or a software engineer would do. So I think there's a lot to be learned from product design. And in fact, my old boss at Apple, she was very much into that as well. I think she pretty much came from product design before she came a engineer and then a manager. And I think she had a pretty good influence on me about this perspective. So keep that in mind. Keep in mind that a lot of design can boil down to the same thinking that you might have as an engineer. Granted, you might not think like a designer, but these are questions that I think a lot of people should really ask themselves. What shapes should something take? So, Johnny Ive's impact on design, and you undoubtedly picture modern Apple products, industrial reform distilled essential components, sure. But let's see. Okay, so it's an aesthetic 180 from what you might expect. Along his team, I developed a seal for Terra Carta, an environmental initiative spearheaded by Prince Charles. Okay, yeah, so this is what I'm talking about. Like, what kind of seal, what kind of artwork would you want for like a environmental initiative? Well, I guess something that reflects royalty, like Prince Charles, and then like the environment itself. So this kind of makes sense when you think of it from that angle, right? The steel is organic, and then there's a lot of different like little details in here, like butterflies, birds, flowers. I like there's so many marks, and then he says that the logo is meant to look alive. So I guess that's kind of like the what's it called, the actual form in which he's trying to follow. So I guess like when you think of that as your North Star, you want to make a logo look alive. Well, how does it look alive? And then combine all these different principles, and like the Royal Crown and the environmental initiative. This logo definitely makes sense. But then the question is, like, even though you know why it makes sense, the question is, could you actually create something like this yourself? What would be your interpretation of it? So I thought this was actually pretty fascinating. And for me, I think when it comes to the Royal Crown, I think definitely that's something that should be emphasized. So there's no doubt the crown should be there, but I would have probably put like a throne or something, like a throne surrounded by vines. But that's why he's Johnny Ives. So let's see, look more structurally, and you'll see the structure is built upon 7 interlocking rings. Holy shit! These circles hint at the Bauhaus sensibility that grounded much of Ives' work at Apple, but that's where the Bauhaus and the project ends and begins. Interwoven among the vines sits a tight space developed by love from itself, love from serif. These letterforms are decorated with extra flourishes at their tips, the exact flourishes that Bauhaus is so dutifully filed away. Oh shit! Yeah. Look at this. So they're talking about like these circles here. I completely freaking missed that. Like for these vines, it's actually kind of interesting. Like you'll notice like all these circles, and then like they have a little wisps on the what's it called, on the fonts as well. That's really cool, actually. All right. Anyway, I think the marketization of different design application disciplines is often arbitrary, and I think it represents an impediment to doing new and useful work. Okay, so he's basically kind of breaking from tradition, and then I guess like saying it's more of an inspiration. But I guess to kind of wrap this up before I bring on my client, this honestly looks kind of insane. Like it's really aesthetically wonderful, but you don't really understand why. And even though you can point out like all these different aspects of it, like if someone in here is like good at product design, explain this to me. What makes this like great? It's absolutely mind blowing, and it's actually quite amazing to watch. So yeah, I very much appreciate this actually. So okay, so 7:59. Let me go ahead and jump into the Zoom call with my client, and hopefully he picks up.
Recording in progress.
Okay, let's see what you got here. I'll keep in mind that he didn't show up for replay analysis last week, so I basically didn't have a stream that day. But I think that I showed you guys that last Friday, going over his dynamic programming approach. And so this week, let's see how well he did his dynamic programming stuff. I guess until then, if there's anyone in the chat who wants to ask me questions, hi, my name's Edbert. I'm an ex-Apple senior engineer who currently works at Uber, and I coach people on how to get good at the coding interview. So if you guys have any questions regarding coding interviews, career, engineering, or anything in general, feel free to ask right now. You kind of have a minute left. Okay, let's see what he got. It says. Okay, he's not picking up for some reason. Huh. All right. I guess we'll briefly talk about like what we tried to get him to do from last week. Get the pseudocode more to a point where it's like plain English sentences. Kind of think and explain like a 5-year-old. I think maybe I need to emphasize that. Yo, hello.
Yeah, but
Hey, how's it going?
good. How you doing?
Hey, doing good. You got my message from last week about your replays, correct?
Yeah, I did read through them.
Great. Let's chat about like how you spent the weekend and how much progress you made. Yeah, give me the rundown.
Sure. So I just got back from vacation on Saturday. So obviously last week I didn't get to study as much, but I did try to cramp in some DP problems, mainly through like I did like a couple problems from EPI, recorded both of them, two of them, and sent to you, which was the ones you reviewed. But I also did. I think I mostly did my DP practices on grokking.
Mm-hmm.
And then since I got back on Saturday, I also went to the LeetCode and practiced some Google tag questions because they do have like some DP questions. So I got to get some practice in there, and then as well as reading on DDIA. The other thing I was trying to do when I'm when I'm doing new problems now is kind of take a second to consolidate my thoughts before I write my pseudocode. That way, I don't end up writing a lot. I could, it helps me write cleaner pseudocode, which was one of the things we talked about last week. I feel like the one thing I didn't get to do much on was reverse engineering. I did try it on like one or two problems, but I didn't feel like I got that far with it.
Okay.
But yeah, that's pretty much the overview of like what happened since then.
Okay, so you basically decided. Okay, so you kind of just like did half. You got a little bit better at the explanation and the planning of sentences, but you didn't really try to reverse engineer any of the EPI stuff. Is that correct?
Yeah. Like I tried reverse engineering them, and it's like with certain problems, I feel like I could kind of identify like where I was, where I didn't think through, but I still kind of failed to see like how exactly. I guess like I wouldn't say like for every problem, but maybe for some trickier problems, like even if I do kind of see like what I didn't think of, like I'm not exactly sure like how seeing that or like identifying that would help me with new like other types of problems, if that makes sense. I know it's kind of confusing.
Yeah. Like elaborate for me. Give me like some specific examples.
Let's see. Let me pick a problem. I didn't get to write a lot on the diary, but let's see. Shoot, I think the text file I was doing that on, I didn't save it, and it got sorry, I
Okay.
kind of lost that one.
Okay.
But the gist is that I did the reverse engineering on a couple of them, and I think for some of them it was fine. Like I could clearly see like, I didn't think of this or I didn't think of that. But I'll try to type it out and I'll send it to you after the coaching session.
Okay, because I think it's really important that you actually look at EPI and really look at their solution. It's one thing to say, "Oh yeah, I kind of messed up here and here," but without like a true north star, without like something from the book to actually give you some guidance, it's very difficult
Yeah.
to do the self-evaluation. I'll tell you this much: like I can't
Okay.
even do that. I've tried this myself. Self-evaluation is absolutely giga difficult, right?
Yeah.
Just because like you don't know what you don't know. So I would highly encourage you that if you can like you do a lot of it. So actually, let me go
Okay.
ahead and open up the book, and let me open up your schedule for a really hot second. So actually, I might
Okay.
as well share my
Sure.
screen. So I'll give you like an example.
Okay.
All right, cool. So you see this book?
Yeah, I see it.
Yeah, I think we did you did Levenstein distance, right?
Yeah,
Like,
I did.
yeah. So if you see here, like you like really, you said like you thought you had done it right or wrong. The book just does the recursive version of like dynamic programming, and then but then it's like I think you also missed out on the self-evaluation because you didn't actually look at what the book did and try to translate what the book did into and how it relates to you. And in fact, like when I did the write up, I told you, hey, yeah, you're misusing it. All you did was really write the dynamic programming version of this part, and you just funneled all your code through that. When instead you should have actually said, hey, yeah, well, for the instances, when we do a replace operation, we run into this branch. And then the other places, when we do like addition, deletion, or everything else, we'll run into this branch. And all I did, like, it took me 10 seconds for me to figure that out. And I think if you spent like just those 10 seconds, you should have done it. So my question to you is, why didn't you do it?
I didn't do it for this particular problem. I guess I like totally missed out on like going back to it because I eventually went to grokking and I continued doing like some prompts in there. And then when I finally got to the edit distance, I realized it was the same problem. I kind of just like retried the problem. And actually, like after doing like a few more practice on grokking, I was actually able to get to the solution without help on the second try on grokking. And it was the array approach. Like I started with the naive, and then like I don't know, like I think like just the way I was handling the base cases, or like when one string is at the end of it. When I was trying to handle that during the first time I tried it, I had a sloppy way of doing it, and like that kind of screwed me over. But then when I did the second time, became kind of clear to me how I could have handled the edge cases better. I was able to focus a lot more on the gist of the problem, which was replace deletion and insertion. And I was actually able to kind of get to the correct solution to it,
Okay.
and that's why I didn't go back to the book and look at why I didn't
Okay. Okay.
I didn't
Okay.
reach the solution on the first try.
Okay, because I'm looking at your study schedule, and one of the things we really talked about was really practicing this pseudocode and reverse engineering thing, and the fact that you didn't do it
Yeah.
is kind of concerning. It's actually
Okay. Okay.
it's quite concerning. You see the
Okay.
study plan schedule?
Yeah. Yeah. I see it.
Yeah. So this is this is a
Okay.
big red flag. Hold up, let me write that in.
Okay.
I need you to do this.
Okay.
Okay,
Sure.
and you said you had a Google phone screen, right?
Yeah, I have a Google phone screen, and then the Amazon onsite, the recruiter came back to me. They actually scheduled it pretty far ahead with the dates I gave them. I think they scheduled it on the 30th.
Okay. So they scheduled for you on the 30th. Okay, that's fine. We can work with that.
Yeah.
All right. So I'm thinking about based on all the feedback that you gave me. I want to check your EPI actually. I want to check. You said you did arrays. I think you don't have much problem with recursion. So I'm gonna do a spot check on you, and then let's see
Okay.
how that goes, and then I'll dive into a little bit of system design. Sound good?
Sure.
All right. Okay. So yeah. I guess to address the live stream, there's a question here about what reverse engineering is. So the reverse engineering is when you really look at a problem and then you look at the solution and then you look at how you can arrive at the book's solution by just simply saying, hey, what did the book do in order to get their solution? What were the step by steps, and what is the difference between what I did and what the book did? What are the steps that they took here, and how could I have achieved something similar? So, okay, so let me go ahead and give you a question from the book or somewhere.
Sure.
Okay, let's pull up something. Okay, so do you think you're good enough to run through a hard problem?
With like DP.
No,
I
just
could.
a hard problem in general. Uh,
Oh. I I've attempted hot prompts, and I feel like it comes kind of boils down to like if like what topic it's on. But I
Okay,
feel like yeah, I could try a hot
okay,
prompt.
yeah. If it boils down to the topic you're on, that's a very bad sign. It shouldn't matter what topic it's on.
Okay.
So
But yeah,
that's a very bad sign. This is concerning.
okay.
Okay, so
But
I'm gonna
in general, I do feel a little more comfortable regardless of the topic
okay.
with what I practice. Like definitely, I definitely feel comfortable
Okay.
approaching a hot prompt right now than when we first started
Okay, wait,
coaching.
but okay. So before I get started, like, well, tell me why you didn't do the reverse engineering or like that whole exercise because it's really important.
I think the main thing I didn't do it was just because like I didn't like I was on vacation, and when I got back I just felt like I wanted to kind of get more like new problems practice in. But I did do the reverse engineering, just not as much as I should have. But
Reverse
I
engineering
definitely
is
did.
almost as important as the problems themselves, even more so. So that way you don't repeat the same mistakes.
Okay.
Yeah. So I
Okay.
need you to be disciplined about this.
Okay. Okay.
I'm
Got it.
really
My
not. I'm
bad.
not joking, dude. I'm not joking. Here.
For sure.
So, all right. So let's start with the hard problem then. Let me start the timer. Okay, here we go. So here's your problem. So suppose that I gave you a array of transactions where the transaction array represents from, to, and amount. These represent like people loaning each other money and then and giving it to person one to person two, right? So I want you to remember. I want you to return the minimum number of transactions required to settle this debt. So let's go through a few examples. So the first one, suppose I gave you a bunch of transactions here, 0, 1, 10, 2, 0, 5. This means that person 0 gave person 1 $10. Person 2 gave person 0 $5. And in order to settle this debt in the minimum number of ways, the person 1 can pay person 0. And one way to settle debt is that person 1 pays person 0 and person 2 $5 each. Because, if person 0 gave person 1 $10, then he needs to get that dollar back, right? Does it make sense?
Yeah, I'm still reading through it.
Okay.
Even from to amount. Okay, so in the first entry, person 0 paid person 1 $10, and then if we just have that, person 1 needs to pay person 0 $10 back to settle that.
Mm-hmm.
And then second element, 2 paid 0 $5 each. I mean $5, and then so okay, yeah, I get the first example. Let's go get the second example
Mm-hmm.
right now. Okay. Based on problem, it seems like we definitely need to, like, the first intuition is that I would need to um, keep track of like who has an outstanding debt that needs to be settled.
Okay.
If that makes sense. So I'm just gonna take the examples and kind of write down some of the stuff that may be helpful.
Sure.
Copy over. Okay, so first example, we know that person 1 kind of owes person 0 $10, and then from the second entry, we know person 0 owes person 2 $5. Okay. Let's see. So I think that the tricky part is going to be keeping track of the relationships between these different people, and from there we could kind of work our way through it.
Okay.
And that's why I'm like trying to see like how exactly we can record the relationships in a efficient way. I'm definitely thinking about like using Hashmap as a way to store like some of these records. Let's see. Person one, person zero. Two transactions. Minimum number of transactions. So I do have one question. If person A owes two different people money, then that's gonna be two transactions, right?
If person what? If person one owes what?
If one person owes two people money,
Mm-hmm.
that's gonna be two transactions, right?
Uh, maybe. Yeah, sure. Yeah, I think so. It depends on the situation, but I believe that in most cases, yes.
Okay. I'm just gonna look at example two as well
Sure.
to kind of see because it's the
Mm-hmm.
big example.
Yeah.
Um, okay. Let's see. So if I were to use like a hash map to kind of store the relationships, after passing through the array once, we would kind of have thinking like using the same for what I've written here. I would kind of have person one would owe the two person, and then this would be the money, and then zero would owe two five.
Okay.
Now from there, we have to start processing the uh, number of transactions needed to settle this. One percent zero. Okay, I'm not sure if this would make sense, but if we were to do this in a naive solution, I guess like after passing through the original array,
Mm-hmm.
if we don't care about the minimum number of transactions, I could basically just do the number of elements in the hash map
Okay.
in terms of transactions. That would definitely give us an answer, but that wouldn't be the minimum.
No, it
Um,
would not. Why?
yeah, yeah. Let's see. Um, 1 2 0 2. Okay. Like I was thinking that this with this example, like I kind of struggle to see how this would work.
Okay.
But I was thinking like if we were to have a hash map like this, I could basically pop uh the keys and the values of it and basically settle that transaction kind of like a one by one fashion. And like I feel like this with this example I kind of struggle because this would still work even though I know the answer is saying that person one could have paid person zero and person two $5 each. But we could also say that person one can pay person zero $10 and person zero could pay person 2 $5, and that's also 2 transactions.
Mm-hmm.
So I'm gonna use the second example, just because like with the first example, like I'm kind of failing to see how this would work.
Okay.
But let me see if the second example will kind of help provide me some insights. Okay, person 0, 1. Sorry, 0, 1, 1 with 0, 0, 0, 1. Okay.
Okay.
Let's see. At
I
this
will say
point, we
that
probably yeah.
I will say putting this in a hash map doesn't really help you that much. All it is just massaging the structure that you have. It doesn't fundamentally change. Doesn't make any progress towards solving the problem. So I'm curious, like, what the hash map is used in service of. Like,
Because
how does this help you solve the problem? Let me ask you that.
okay, because the original intuition I had was because like there are like multiple relationships that we need to keep track of, and that's why I thought of using a hash map. But like you said, it doesn't seem like it's helping me in any way. Okay, if not a hash map.
A hash map may or may not be useful. My question to you is, how does the hash map help you at this point?
Okay. So I'm kind of like what I'm thinking about using the hash map for is like in this particular case, we know that person 1 owes person 0 $10. And then when we get to the next element, we know these are the two like the same people. And I was thinking like, oh, okay, like I know that person 0 now paid person 1 paid person 0 $1. So we should kind of be able to check to see if this relationship already existed and kind of deduct that amount.
Okay.
But I'm not able to get the key. Actually, let's see. If I'm over here, so I have from to amount. If let's say Q is in hash map. Let's see. Are they the same people? If it has a transaction with same person. So in order to keep track of like multiple transactions, it seems like one single element would not be enough. Like I would probably need multiple, like an array for the value of hash map. So that way I could kind of keep track if one person owes multiple people money. So say if person 2 paid person 1, let's say I use a new one, person 1.
Okay, so so right now you're basically saying, hey, instead of having a list of transactions, you're now going to specify who owes what person what amount of money. How is that fundamentally different? It's like it's just going to say, hey, if one of the transactions is giving person 1 from person 2, like if one of the transactions is person 1 giving person 2 $10, then you're going to record that person 2 owes person 1 $10, which is pretty much the exact same thing that's happening in this transaction. So it's I still fail to see how you're solving the problem. It's just reshuffling the input.
I agree with you. I'm just gonna take a few seconds to
Sure.
kind of think about this.
Okay.
Okay. I'm not sure if how this would work well. I'm thinking like what if I record people that have debt,
People what?
people that need to settle transactions, people who need
Okay.
to pay money back.
Okay.
So if I were to do that from this, I would kind of have something like one needs to pay $10, person one also need to pay $5 based on this. So I'll just kind of add on to that. Person zero needs to pay $1. Okay. 0, 0. Okay, I'll add on to that. But with this, I'm not able to kind of negate certain transactions and kind of just cancel them out.
Okay.
Because I know, wait, let me look at the example. There's one dollars. Because if we have something like, let's say, 125, 215. I don't want to kind of record this. I want to be able to kind of cancel them as we go.
Sure.
Okay, so if I were to do that, I'll have something like this and like that, but that wouldn't help. At any element, how do I know if this transaction negates this? 215.
Right. So if you have both these
Okay,
transactions, then
yeah,
effectively you end up with a net zero, correct?
yeah, correct.
Okay.
So this is where like initial like this was what kind of prompted me to have the hash map originally, but it didn't seem to help me to capture the relationships the way I picture it would.
Okay.
And that's why I kind of resorted to see like if this other way of recording these transactions would help, but because they don't keep track of the relationships, I would not be able to negate the transactions on the go. So I'm trying to think of like what other structures or in what other way I can record these transactions in a way that allow me to do this. To
Okay.
1, 2 is, let's see.
Okay. So you're basically trying to see
Yeah.
if one transaction negates another. I'm gonna give you two examples here to show you this may or may not matter. So let's do an example here, right? So suppose
Okay.
I broke this up into 2, 1, 2.5, and 2, 1, 2.5. You know, this would effectively be the exact same result. Another thing you might want to think about here is 1, 2. If 1, 2 owes gives them $5, right? And then 2 to 3, yeah, person 2 gives person 3 $5, and then person 3 gives person 1 $5. This would essentially mean 0 transactions are needed. I want you to think about these two examples here.
So, okay. So for the second example, I still I'm still having the same idea.
Okay.
The way I would negate it is kind of keep track of the amount as well. So I would kind of deduct the amount from what was recorded. So say I get 5 and I'm able to kind of map that relationship, I would deduct 2.5 from it. And so person 2 would still owe person 1 $2.50. And when I get to this, I'll basically do the same thing. And when it gets to 0, that's when I know it could be discarded. So for the third example, let's see how that will work. Person 2 owes person 1, 2. Okay, so 1 to 2 is $5. So I guess I would need a way to be able to kind of do something like, if I have like 1 to 2 and 2 to 3, and they're the same amount, I could kind of do something like 1 to 3, 5. So if I'm able to kind of merge these together,
Well,
when I
this
get
is 3 to
to
1. I said it did 3 to 1, so.
yeah, and then when I get to 3 to 1, I could kind of negate it.
But okay. I think
But
that's vastly complicated because you're
yeah,
now trying to follow a bunch of transitive properties that may not necessarily pan out. Because what if this is 10? It gets very confusing here. So I would say try to think a little bit simpler.
okay. Um, yeah, so far it seems like all of the initial approaches that I have in mind do not seem to work out for this problem.
Okay.
And I'm trying to think from like a different perspective.
Okay.
So like how exactly like in what other ways I can tackle this problem. Uh, 0 to 1. All right. Let's see. Hmm. So I'm kind of just running through like options I have.
Okay.
Stack would not be helpful here. A queue would not be helpful as well. Um,
Okay.
so
How about
the
instead of
only
trying to run through data
yeah
structures, how about you try solving the problem? I'm going to tell
okay
you right now, like throwing random data structures at this problem will not magically yield a result. There's no such thing as a magic bullet. I think we've talked about this before.
yeah um,
All right, I'll give you a hint then. Does it
okay.
matter when you're considering a massive number of transactions? Does it really matter where all these transactions, who should pay who, or can you resolve that all at the end?
If I don't care about who owes who, um,
To person, yeah, like as an
yeah,
example,
yeah,
if person 2 is owed $10, does he
yeah,
care whether it came from person 3 or person 1?
maybe not exactly. Um, if okay, so that would be kind of similar of like what I recorded over here, right? I basically recorded how much in total each person owed in the end. So person one, 15, 0, 0, okay, 2. So in the end, I would kind of have this if I just recorded basically uh, how much each person owes in the end. Now, with this, I can just say like depending on like how much money I have here, how many elements I have here, I could just kind of say like I could just do this amount of transactions.
So what do you mean?
But so in the end of processing through this array, I know that the people owe this amount of money each. Even though
Who owes what? Because all these are positive numbers. How do you identify debtors and collectors?
that was the issue, because I was only recording how much a person was given from other people.
Mm-hmm.
So one was given a total of $15 by
Okay.
other people. I don't care like who gave it to him, but
Right.
and this is why I have these numbers. But the issue is that I'm not kind of tracking the depth, the who paid the money and who received the money, and that's why I was so hung up on recording the relationships, because without the relationships, I'm not able to kind of negate some of these transactions.
But like I
Or like
said,
kind of
it
yeah
doesn't matter if person one or person two is solving person three's debt or credit. It doesn't matter. Like I said, it doesn't really matter who pays that debt. Because in a sense, because remember that example I gave you, if person one owes person two $5, person two owes person three $5, and person three owes person one $5, then no one owes anyone anything. And so you decide
okay
to just try to map out the entire relationship. But even then, that's not guaranteed to necessarily be the minimum number of requirements, the minimum number of transactions, right?
yeah sure
I mean, this is like
um
so. I'm going to give you like 2 more minutes because I know you're not. I'm pretty sure you're not going to get this problem.
okay uh okay, so if I'm thinking like what if I were to do a second pass once I have this.
Okay.
So in the first pass, we would kind of record how much money a person was given.
Okay.
So this would record in the end, like we know that in the end, like one person, person one needs to pay back $5, and person two needs to pay back $5, person three needs to pay back $5,
Okay.
so on and so forth. And in the second pass, I would kind of do the opposite, and I would check how much this person has given out.
Okay.
So in that case, like we know that person one has given out 5, I would kind of negate it to 0, and then I would kind of eliminate that from
Okay.
whatever data structure I have.
Okay.
And I'll kind of do the same thing for the rest of these. So that seems to work for this this example, but let's see how this would work. So I recorded how much a person has been given. Now I'm gonna do a second pass to see how much that person has given out.
Okay.
So person one.
Let me ask you: do you need to do this in 2 passes?
Probably not. If I just do positive and negative numbers, I would just keep track. If it has given out, I'll just do negative, and if it was received, I'll just do positive. So let's actually see how this would work out. I'm just gonna take this away so that it would be the same as the example you gave me, and that way I could kind of validate it with that.
Okay.
So first we have person. Okay, I was using the two person as. So it was given $10. And then we know that person 0 has given out 10. And then when we move on to the next element, person 0 has received 1. So we would do -9 with +1. And person 1 has given out $1. So this we would decrease that. And then when we get to the next one, person 1 gave out 5. So this would minus 4, and then person 2 received $5. When we get to the last one, person 0 received $5, so we have -4. Person 2 gave out $5, so this would be empty. And let's see, I have 2 transactions left. Now these two are the same, and we only have two people. We know that they owe each other money, and that way we can say only one transaction. But
Mm-hmm.
if we were to have multiple people, um, let's see. I'm not sure how that would work, but I feel like
Right.
this approach may
Okay.
may kind of help if I
Okay.
had stumbled upon this earlier and had
Mm-hmm.
more examples to try this on.
Okay. I think right now, I will say you're on the right track. So the question now becomes, how do now have a list of debtors and debtors and creditors.
Yeah,
The
yeah.
question now is, how do you want to resolve this?
I would need to find like matching. So like one idea is definitely if this was a simple example
Mm-hmm.
where we have one person owe the other person, and like it's kind of like all the debt and collectors are groups of two. We could just kind of count like the amount that kind of add up to zero.
Okay.
So adding up to zero is definitely the way to go. Now I'm trying to see like how with multiple. So say I would have something like say this is person two, and it has two. We know this is also this could potentially this would still have to be this would be two transactions. Um, let's see, -0, -4. Okay, this would be two transactions. We have the net. Okay, so here like I would pick the negative number, and I would just from all the positive numbers, I would just kind of add to it, and the amount of times I add till I get zero would be the number of transactions.
Mm-hmm.
But if I were to have more, let's see, if I have like -5, this would be 2, 3. Okay, so if I'm recording, okay, if I'm recording the given and the the given like the total amount of money given and the total amount of money collected
I don't
or
think this is
received.
right. Are you still going through
Yeah,
this? Okay.
yeah. So I'm just trying to say like if I'm recording the total amount of money given and the total amount of money received,
Mm-hmm.
the end result should ultimately negate itself to zero. That's
Mm-hmm.
kind of what I have in
It's
mind.
a closed.
Because
Yes, this is a closed
yeah,
system. All the money in given all the money that's in the system is going to net zero when you sum it all up.
yes, exactly. So the question now becomes how do I kind of get to the point of zero
Mm-hmm.
and knowing when to increment that count of transactions.
Mm-hmm.
If that makes sense.
Sure.
So now I have like two negative numbers, three positive numbers. We know ultimately this is going to be three transactions.
Mm-hmm.
This is two transactions. So if we count the number of okay,
Let's start
yeah.
here. Instead of like trying to come up with some fancy way of doing it, what's
Yeah.
the simplest dead brain, easy, like smooth brain, fucking child way to solve this problem?
Based on what I'm seeing here, it's counting the number of people who have a positive integer here.
Mm-hmm. Well, that's counting. Let me ask something different. It's not necessarily counting.
Oh, it's not necessarily counting.
No. What's the easiest way to solve this problem without trying to be fancy?
With what I have here,
Yeah, it doesn't matter. In general.
basically get sum everything up to zero.
Well, you
No,
sum everything up to zero, but how does
yeah.
that help you record the number of transactions?
Okay. It's Do you mean I would basically just don't care about the minimum number of transactions and
No,
I'll
I'm
just
saying you do care. I'm asking you what is the easiest way to get that number? Irrespective of runtime or memory, what's the easiest way to get that number?
uh count all possible wait. Uh my brain is kind of telling me like counting all possible ways to make this 0, but that doesn't quite make sense. Um, uh, 2, 3, 10.
I'm gonna give you 2 minutes on this. If you don't make any progress, we'll put a plug on it and go
Okay.
review. So
Okay. I don't know if this makes sense, but it kind of feels like if I were to. Okay, wait. You said no counting.
what's the easiest way to do this? Solve this answer.
Um, let's see. If I were to do okay. Easiest way if we take two elements at a time and add them. Um, I
I'll give you 30 seconds left.
Okay.
And we'll stop here because I think I know where you're gonna go and I think you're gonna get stuck. So
Okay.
okay, I'm gonna pause you
Okay.
here.
Okay.
Unless you know it.
No, like my idea still revolves around counting. So the fact that you said without counting, kind of, I'm not able to see that.
Okay. I'm gonna put a pause here because it's basically we're at 37 minutes, and I would have liked you to at least get the idea down. Because in the best case scenario, if you got the idea like right now, and you coded up, it would take and tested it, it would take you 45 minutes, which is the average length of a normal interview. So,
Okay.
if you can't get the idea down, then there's no point in trying to ask you the code or take the full 45. So,
Okay.
Question: What do you feel like you did right? What do you feel like you did wrong?
I definitely I feel like I wasted like more than half of the time on my initial approach
Mm-hmm.
of like being very hung up on the relationships.
Mm-hmm.
Like even when you told me to like not use a hash map, the other ways I was thinking through still kind of revolve around the idea of like keeping track of the relationships. So I think like it was like not abandoning the idea, but just kind of like wrapping it with different wrappers, but still kind of on the same idea, which wasted most of my time.
Mm-hmm.
It wasn't until you gave me the hint of like not needing to keep track of the relationships that I went back to look at the part where I recorded the total amount of money owed. And I think the part I did right was suddenly thinking of like, okay, what if now that I have like the total amount of money owed what if I do another pass to kind of negate that number, and then as well as also doing a one pass and doing that simultaneously. Um, but yeah, I think like I feel like that was the only part that I feel like I did okay. I think everything else I did was like pretty bad, especially in terms of like the approaches I was trying to come up on. Like I was just trying to think of like what data structures I could use, or like what things could help me solve the problem instead of like directly tackling the problem.
Yeah, pretty much. That's all it boiled down to. You even recognize it, and I think we've talked about like shit like this before. You know, so let me go over my notes. One, yeah, it's like, oh, let's use hashmap to store the method. You know, yeah, you're right. It took you 15 minutes to realize, hey, wait a minute, hash maps aren't helping me. And we've gone over this idea before of there's no such thing as a magic bullet. That you need to know when to give up on your idea, especially since you've practiced it before. You already know. I assume that you're pretty comfortable with hash maps. If not, then we have a bigger problem. So you know that how hash maps work. You don't need to finagle with that. And it's not immediately obvious how hash maps work. I told you basically over and over again that, hey, you using a hash map here does not fundamentally change the problem. And the one point I want you to remember is that data structures are in service of actually solving the problem, not the other way around. You don't use data structures to as a solution to a problem. You solve a problem and then use data structures to implement it. I want you to get this idea down because I think this is going to help you. So, after that, you finally came up with the idea of what you were saying.
No, I think like the even though when you told me not to use a hash map, I was still trying to use something else because like I think at that moment I was still very hung up on like I need to record the relationships, and so it didn't really matter like what data structures would come to mind. Even, like just that hash map was the first one that came to mind in terms of recording relationships. So it wasn't like I was trying to use a magic data structure to solve the problem. It was just like I wanted to use something to help me record the relationships, which at that point of time I thought would be a key to solve the problem. Until you gave the hint that the relationships is not necessary, and that's when I was able to kind of abandon it fully, because I know I no longer no need to record that relationship.
You tried every single avenue with the relationship, and you basically got hung up on it like really, really hard. You see how that kind of killed you?
Yeah.
Like it took you basically 15 minutes to even 15 to 18 minutes for you to even realize this. And I think we've had previous sessions where it's like, hey, yeah, know when to give up on the idea, and grow the problem logically. I think this is where I'm not reviewing the what's called EPI and doing the going over that reverse engineering is kind of biting you, and I'll show you why. So basically, you I think at 18 minutes, you finally realize that, hey, this is how I solve the problem. Well, at least the first step, right? Of doing the debtors and creditors. But then you end up choking again with this. What's the simplest way to solve the problem? So the simplest way to solve this problem, once you get to this step, is really try every single possible combination of giving money from debtors to collectors and resolve all this. So, for instance, for person 0, give person 1 $2 and give person 2 $3, right? And then recursively go into that. Okay, what happens if I give person 3 and person 4, right? Or let me try, -5 to 10 here, and then from here -10 to 3 2, and then whoever's remaining. Basically, try every single possible way of distributing money from debtors to collectors. That's the easiest way to solve this problem. Wouldn't you agree?
Yeah, I agree. I definitely agree, but it's just that at that point of time, I just couldn't really see how I would try every different combinations. When you said no counting, that I think that's what really got me stuck, because I was thinking about counting the number of persons that have a positive integer and the number of persons that have a negative integer, and then from there I could just kind of see if I could get the one with the larger value.
Okay. But that's what I'm saying. That you need to acknowledge the simple solution first, and then you can go into let me try a greedy approach. Try resolving the biggest debt to the biggest collector. But the fact is that you didn't acknowledge the basic solution to begin with. You went straight for the complicated one instead of just taking the one that's super simple in front of you.
Yeah, I did mention that like one possible way is to try like all like possible combinations, but I wasn't sure like what all possible combinations would mean in this context, and so like
I don't remember you saying that because I
did
literally asked you what the
I
simplest
I
way of asking of
I
answering this.
I did say, but it was more like me talking to myself. Like I think I only said for like half a second. I was like, okay, I could try like maybe all possible combinations, but then I was like, because immediately I was like, how would all possible combinations kind of look like for a something like this? And so I just kind of abandoned that.
Okay, but the thing is that
Yeah.
but you see, like you're talking to yourself. You're not talking to the interviewer. So obviously, I don't know that.
Okay.
So if you have an idea, say it to me.
Yeah.
Yeah, that's it. And then so the question now is, oh, what does that look like? What does distributing all these account balances look like? Well, trying every single possible combination. Try the negative, all the negative numbers. Try distributing them to every single possible combination of positive numbers, and then nest into that. I think that's a pretty easy solution, don't you think?
Yeah, like, but yeah, yes, yeah. In conclusion,
No,
yes.
I don't want you to say yes just to say,
Yes.
yeah, Edbert, I get it. I want you to say
Yes.
yes like you actually understand. Like,
I,
if there's not something you understand,
it's just I know what you mean, but it's just I still don't see how that would work if that makes sense, and that's why like at that point like that wasn't really something I wanted to like pursue.
Okay, so so then you want me to write the pseudocode for you?
You could just uh kind of say like what you mean by like trying like every possible combination. So like, because you mentioned something about like taking this number and summing it with that, and then trying like a different combination.
Sure. So let's try. Let's actually go through step by step. So let's say this is my initial transaction, right?
Okay.
So then the first one I'm going to try is I'm going to try distributing from all my debts to collectors, right? So let's start with patient number 0, right? So we're going to go -5, and then we're going to give it to 1. It's 2, right? So then what it's going to look, the account's going to look like after that is I'm going to see I'm going to see 3 to represent, hey, I'm paying this guy back, 0, right?
Yeah.
And then we're going to recurse again for distributing all my debts to collectors, right? So then here, I'm going to say 0 to -3. And then, hey, I'm going to give money to 2, right? So then now I end up with this situation here, right? 0 and 0, right? And then we're going to repeat the exact same thing. Each time we distribute debts to collectors, right? Oh, here's another debtor.
Yeah.
3, and we give it to 4, right? And each time I do a number of what's it called? Num of transactions plus each time I do this, right? So you understand this so far, right? So then let's say I do that, and I end up with this, all zeros, right?
Yeah.
So then here would just be record the num of transactions that I've run into so far, right?
Yep.
Okay. So then now we recursed enough. Now let's backtrack, right? So I've distributed all my debts to collectors here. Boom, 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 right? I'm popping out here. Pop out.
Yeah.
Right. So then now I've already tried distributing -5 to 1 and 2, right? So now I'm gonna try distributing this guy. Was it -3? Distribute again. Distribute from -3 to 10, right? So then my ledger is gonna look like this. 0, 0, 7, right? And then, okay, well then let's try again. And the num of transactions plus. So here, let's go to another one. 3 -10, distribute all my debts to collectors. And then here, let's try giving it from 2 to 3, right? So then, what's gonna look like? So you get the idea, right?
Yeah.
So all I'm doing is trying every single possible combination of debtors to collectors. And I'm just doing this recursively and backtracking. That's all this is. Does this make sense?
This does.
And I feel like you should have seen a problem like this before if you did like the recursive section in EPI. Or like any kind of permutation or combination problem.
No, I didn't do this one in the book.
Okay, let me actually see. Let me see your study schedule then. Did I assign it to you? I assigned you recursion right before you did before you went for vacation. Did you skip some problems?
Yeah, I did skip some problems.
Okay. So which means that you need to go back and do all the EPI book problems.
Okay.
Okay. So I'm gonna write that down. But yeah, basically, what other problems did you skip in EPI and that you didn't do the what's called reverse engineering for?
Sorry, say that again.
Yeah. Okay. Yeah. Like, what are the other problems that you skipped?
Like, didn't do or didn't do the.
You did not do an EPI.
I have some in recursion, some in DP. Do you want me to just list them?
I assume that you have a record, and I hope you do have a record of the problems that you did.
Yeah, I do. Do you want to just pick a random one?
No. So basically, what I'm trying to do is I try to adjust like how to, yeah. This is okay. I'm trying to adjust like the schedule for you, like what we need to cover because I do want to talk a little bit about system design today. So
okay.
Yeah. So I do need you to do greedy as well.
Okay.
So I'm gonna need you to do recursion and greedy.
Okay.
So yeah, I knew that we were gonna need you to do this, and you didn't. I knew this was a red flag, and here it is biting us in the ass because, like you could make the argument, oh, this is like an NP hard problem, and therefore we use greedy in order to make it run faster. It's not gonna give us the most accurate answer, but it will get us a faster answer. That's perfectly acceptable reasoning for this problem. But to me, like you just said, oh, it's obviously that we have to match biggest to smallest, and that's not necessarily true here, because again, it's NP hard.
Okay.
Okay.
Yeah.
Yeah. So what? I need you to really not just like don't be a doormat for these problems. I really need you to fight for your ideas, and I need you to really like do the stuff that you're assigned to do. That's it.
Sure.
So then I know that I was a bit harsh on you. Do you need 5 minutes breather, or you're good to go?
I'm good to go.
Okay. So let's talk about the system design because all this is really going to do is just going to stem from everything we talked about here because I don't want to have to repeat myself for a lot of these things. Like for instance, like explain ideas like you're 5. Walk through problems step by step and really try to make sure that you address every single thing before you move on. Address the first thing before you move to the next one. These ideas do not change when you go to the system design problem, okay? This does not change. And the reason why is because this will allow you to actually, and I want you to take notes on everything I'm saying here, by the way.
Okay.
So, and this does not change because when you grow, like in engineering in general, I'm gonna give you a little spiel right now. In engineering in general, you're going to build a system from minimum viable product to a bigger product, right? LinkedIn was not built in a day. LinkedIn wasn't like thought of like, oh, let's make a 1 million user or 100 million user system. No, they started off with like 10 people, 100 people, and then they grew the system from that. And the system design is going to be pretty much the exact same thing. Now, the only difference between someone like you, me, and let's say a senior staff, principal engineer, right? The only difference is that they actually just can do this faster. What do I mean by this? So for instance, let's say you had a minimum viable product of, let's say design, was it like a, I guess LinkedIn, let's say LinkedIn is one on the topic, right? So they're going to have like a website, website database, and then, website, backend, database. Something simple, right? And then let's say that since, all this, or let's say MySQL database, for instance, and then they'll say, oh, well, most of LinkedIn is built on relationships. So instead of having a backend hooked to MySQL, it's going to be faster for us to do graph database, right? And so after that, it's like, okay, well, now we need to be able to scale our backend infrastructure to accommodate more products. So then our backend might actually might break up into like a actual server, ingestion engine, ingestion engine, and then, you know, with multiple requests to the database, you might have a job scheduler for the DB, you know, and then after that, it's like, oh, well, we have a shit ton of traffic, when even though we might be able to handle those things on a server, we might need to start replicating. So you see here, basically, the only difference between what I'm doing here and what a staff engineer is going to do is basically, hey, he's going to skip all these steps because he already understands all this. So when you see people like really design and pick things like right off the bat, that's only because they're doing all this in their head very quickly. They understand, they don't have to walk through this exercise because they already understand and entail what each step entails, and they can break it down if they need to. And that's basically where we're going to start off. We're going to start off with this logical thinking of this breaking down, right? And then after that, we'll get faster and faster and faster as we do these. Does this make sense?
Yes.
So I'm going to ask you right now, what is your exposure to system design? Have you practiced it with anyone else? Have you talked about it with anyone else? How has that gone for you?
As far as system designs go, the stuff that I have read on or like done is read a couple of chapters from the grokking one, and then obviously reading DDIA that you gave me. The other resource I have is the system design course by sorry, what is that called again? From Clement. That is the
Okay.
trying to remember the name of that resource. Sorry.
All right, whatever. The point is that these are all basically information banks.
And I have done 2 mocks with a senior engineer from my team.
Okay.
But those were more product focused.
Okay.
In Facebook they call it Pirate X.
Okay.
I think one of it was definitely close to a classic system design, but more focused on the product.
Okay.
And then the second one was you could say like it's pretty close to a pure like API design interview.
Okay, so let's actually try and focus more towards that. Give me an example of Facebook's the question that you asked and what feedback he gave you.
The API one was the design newsfeed API.
Okay.
Let's see. Let me pull out my work laptop. I have the notes.
Yeah, and if you could copy paste them on here, that would be really helpful. I can see like what he's thinking. I can tell you that.
Okay. You're gonna have to give me a second to
yeah,
put it up.
Fine. But yeah, like I assume you've read my guide on the system design as well.
Yeah, I read it.
Okay, good. So I'll copy paste this for your own reference and for the audience reference. But basically, the overall approach is basically going to be, like I said, design minimum viable product, address the pain points or the unknown things that are in the system, and then try to solve it based on certain parameters of what the problem is. So this can mean like trying to follow the CAP theorem as a guiding principle. This can mean like, oh, well, we need to shard a database, multi-leader, leaderless selection, and so on and so forth. So a lot of these resources that you've probably read up on, they tell you what these components are, but they never really actually like tell you how to think and evaluate about systems. I think for most people, they try to end up resorting to let's just create like a website, server, backend. And then say, oh, we'll have maybe some analytics here, and then we'll use MySQL for the for the database without ever actually justifying its existence. So I'll say that's and that's pretty much a very L4 level way of thinking. Like, hey, these prepackaged components work, and this is how they work out of the box. But then the question is now, how do we want to do better than that? Okay.
So I'm just gonna copy some. This is actually not from the API one. This is from the first one I did with him.
Yeah.
Question was design internationalization at Facebook, and the prompt he gave me was that Facebook just launched, and it's only for college students right now, but we want to expand. So you have to design internationalization. And let me copy the. Let's see. These were just kind of, you can see my notes, right? These are pretty rough notes. I can probably add more to.
Okay.
this. Let me. But in the meantime, I'm just gonna try to find the notes for the
I see.
API one I did with him. But this one was pretty bad because like I was kind of expecting like a API one, but it turned out to be more of a product system
Mm-hmm.
design question. And so like in general, like I think the only part I did decent was the um, clarification part. But in terms of like the actual like the other parts of the question, I didn't really do that well. I think the main thing was that I didn't provide enough details. And approaches weren't considerate of the scenarios.
Mm-hmm.
Um,
Now I understand. I understand what happened here. And correct me if I'm wrong, but you went in saying, "Hey, all I need to do is make this work." You didn't think about why it works or how to scale it or what's the future use of the particular product. Am I hitting the ballpark here?
that was definitely one of the issues.
Mm-hmm. I would say it's the core issue actually when I'm reading things like this. How are things sent to the translator? How do these services commit? How do these services and components interact with each other? That's really the core of like the product question here.
Yeah, these were all the things that he mentioned that I should have covered as well.
Mm-hmm.
But yeah, basically like this was kind of like a disaster when I did it with him.
Okay. I'm gonna tell you that right now, like this is not any like the approach to a product based on what how I think the Facebook is going to run this is not really any different than what I've really put out here. You know, you can start with a minimum viable product. Oh yeah, for internationalization, we'll just have a set of strings for what's it called for English, for Japanese, for Chinese, for whatever, you know? And then the question then becomes, well, okay, what happens if we want to add more strings for every single language? How might our architecture actually handle that? Or, like what happens if these strings change? How does our architecture handle that? Do we need to cache? How does our caching mechanism get affected if we need to, add more strings, retranslate some, change some strings, and store these strings? That's basically what we're talking about here. It's a question of how does your product react to change. So let me see your API thing.
Yeah, this one was definitely better when I did it with him.
Okay.
So it was basically just like talking about like how exactly I would design the newsfeed API design. I wasn't exactly asked to write out the function signatures,
Okay.
but more so just to talk about like, like first like the first simple the question started out pretty simple, which was like, okay, we could assume that the backend will give us a list of orders and how we would handle getting the post, how we would display it, as well as comments, lights, and like I think the main thing I focused a lot was like what the data model would look like, and so like what main entities we would have, and what are the fields on them. And then later on, he like added on, which was like, okay, what if the user could scroll pretty long, and like how do we handle like refreshes and stuff like that. And that's
Mm-hmm.
why I brought in like, oh, we could like use pagination tokens when we call those methods. And with a refresh, we could then kind of make a new call, and we wouldn't do real time. But if we needed to do real time, I mentioned that we could use like a long-lived WebSocket connection.
Okay.
And like privacy side, I also mentioned that we would have like an enum to keep track of like the different privacy settings a certain post has, and from there we could kind of deduct on whether we want to. The backend would basically get the list of posts, and then with that token, the privacy token, based on the user we pass in, we can kind of filter out the posts that a particular user is not able to see. And also I mentioned like we could use blob storage for like the actual like images and videos to kind of separate that. But I think like what he mentioned was that my way of handling text was not good enough, because I was mentioning like, oh, we could probably use a string, but then with like this kind of ties back to the last problem, which was like with different languages, and like sometimes we want to do mentions and like at you want to tag like certain people at images and stuff, and that's where I wasn't able to cover very well. But in terms of like, if we don't consider that, I think he mentioned like everything else was okay. But the main thing I didn't do well here was the date format and the caption field.
Okay. I understand. Whereas now I understand. I have a better idea of what they're looking for now. Actually, okay. So I'm gonna assume that at Facebook, you guys are basically focused on, and feel free if I'm like violating your NDA or anything.
Yeah.
But basically, you guys have an architecture that's well defined, and your job is to really think about how to make products, retire them, grow them, and just keep churning them out. You know, boom, 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 boom. Is that more or less the case?
You mean in sorry, say that again?
Your job at Facebook, or at least the expectation of the engineer at Facebook, and it's probably like most engineers at Facebook, they're responsible for churning out products and features and then like sunsetting them and then coming up with a new one all within a quarter over and over and over again within the same architecture.
I feel like we definitely do more reiterations, but I wouldn't say it's as blind as how I used to feel, or like how people do say it. But we definitely do. Like, I'll expect it to chunk out a lot and then like reiterate on it and like pretty much what you said.
Okay. So I'm like 60-70% of the way there. Okay, fair enough. I think the last 30% is probably something else. But okay, so I'm going to give you a few North Stars when it comes to interviews like these. So the first one is how does your product scale? As in, how can it handle changes? What changes are likely to happen? Second one is going to be how will the developer handle this? How easy will it be for him to work with it? And the third one is your users. How will your users handle this? So how will they handle change? Because the one thing that is very constant is change. I'll tell you that. And it's not, and I think I've mentioned this before in previous videos, but it doesn't matter that your product works today. It matters that your product works tomorrow, the day after, and infinity to beyond. Like, we can change the product. We can massage the product into meeting new requirements, And, let's say, like, for instance, tomorrow, the whole thing with iOS, right?
Yeah.
Yeah. So the thing is that with the privacy settings, Facebook's like, oh shit, we don't know like what their phones are. We don't know whose activity maps to who. And before they would actually deal with this like with probabilistic modeling, but now it's like straight up, oh well, we don't even have the user's ID, so we can't even probabilistically model this. So yeah, it's basically all about extensibility and maintainability. But I'm just kind of making this a easy mantra for you to really remember. So bottom line, that you need and the point of that example is that change can happen at any time. How well your architecture handles that change is going to determine how good a coder you are. Can you handle these changes that are likely to happen in the future? Was it likely that Apple was going to do that? But the point here is that change is always going to happen, and you better hope that your product and the way you've designed it can handle all these different things. So how does that apply to what you've done here before? So like I said, one is like, okay, well, you decide to launch internationalization at Facebook. So strings is just one part of it. What else can you think of that might change if you actually, if you decide to internationalize Facebook and it only started off as an English-speaking product?
If it's only going to be an English speaking product,
that's the start.
Then I guess, yeah, and like I could obviously just stick with a string, and like I could have like certain certain patterns that the application will be able to recognize that it's a mention or a tag. So if it was just like a plain, like if it was guaranteed language is only English, then say like if someone has the ampersand character, and then we would recognize that as a mention. And if the user does a backspace, we would then kind of add a escape character there. Oh, like in certain ways.
That's not what I'm asking. Yeah. You're diving into the details of strings. I'm asking you as a product as a whole, what changes. And what changes when you move from a English speaking audience to an international one? What else other than strings?
Are you saying like what else I can use besides strings?
What else in your product might be affected when you start dealing with an international audience?
Basically every content that has text or like yeah has a text field.
You're so focused on strings. What the fuck, man? Think outside. What else can change? Or I'll give you a minute, and if you need me, and I'll give you an example.
Product side wise, we would also need to offer the ability to see translations or like translate to different languages.
Okay. I'll answer this question for you.
Okay.
Okay. Suppose I want to expand to China, and I have pictures of Taiwan all over Facebook. You think that's going to cause some problems?
Yes.
Content. How do we filter
okay.
for appropriate content in one region or another? Or
okay,
here's another one.
I see what you mean.
Yeah,
Okay.
here's another one. Like, what about the users? You know, some users are going to use phones. You know, in 2007, I guess iPhone kind of, right? So let's fast forward. Let's say that there's like a mobile thing, right? Well, some of these people in like in Indonesia or like Southeast Asia, they're gonna be running on like freaking like phones that were like old as fuck or made in 2010, right? So maybe the APIs and stuff that we want to use, or they might not actually be able to handle all the traffic that we send to them, right? That's another thing that your product's going to need to be able to handle. How do you deliver data to people with poor internet connection?
You need more content delivery network.
It could be that, but my point here is I'm trying to get you to think outside the box. I'm trying to get you to think like how your product is affected by all these different factors. So the question is, okay, let's do a very simple. Yeah, and this is what I'm trying to change your mind. Like, don't focus on like one thing.
I see. Okay, so yeah, to answer your last question about like what we can do to send network or like data to places with low internet or like low internet speed is we will also need to add the ability to like allow like lower resolution when loading pictures or videos.
Sure.
That's another thing.
Here's the thing, but that's not what the interview is testing you on right now. And that's what the interview is testing you on is your ability to understand what changes can occur and how you can accommodate for that. And all you're doing is like, oh, well, you're asking the interviewer to throw you the change and then you just solve it. That's not the expectation. The expectation is you can think of these changes yourself. Does that make sense?
Yes.
Okay.
Basically being able to come up with the same questions you asked me by myself.
Yeah. So along that vein, I've given you a few examples. Give me another one.
Okay. Being able to handle different time zones.
Okay, that's decent, but all right. Give me another solid one. Let's hard hitting, like something that makes your CEO go, oh shit.
Okay. So you already mentioned political context. That's a big one.
Look, man, I don't want negative 300,000 social credit on my account.
Yeah. Let's see what else.
I'll give you 30 seconds, and then I can list a few.
Okay.
And I'll help you think of this through.
Okay. So would um okay, I guess this still falls under strings because I was thinking about like
Okay. Here,
uh
let me make
yeah,
this
okay.
easy for you. I'm gonna get. I'll say because
Okay.
you keep coming out with strings. Okay.
Okay.
What's the difference between U.S. and Europe? Or pick any country in Europe. Germany. Let's say what's the difference between U.S. and Germany?
Language, time,
Okay. What else?
uh political situation,
Sure. Yes. Anything else?
um demographic.
Okay. Yep. Anything else?
Definitely a big one is location. Um Culture.
Okay. Sure. Sure. Okay. So you have a bunch of different ones.
Yeah,
How about
yeah.
laws?
How about what?
Law.
Oh, okay, yeah.
Okay.
Law is different.
Okay. So knowing all those different things, how does that affect Facebook?
We would need to like the product needs to accommodate for the all of those things when we make it available in those countries.
Okay. You need to account for that. How are you going to account for that? And what should the product look like to handle those changes?
Um, so from a law perspective, obviously we need to know like what the laws over there are, and we need
Sure.
to do like say privacy reviews,
Mm-hmm.
security reviews to make sure the way we handle data
Okay.
compliant is in compliant with what their law is.
Yeah.
In terms of political context, good one would be like you mentioned China. We obviously don't want to show content that suggests that Taiwan's a country if we were to want to make it available
Okay,
in
but I'm
China.
talking about all the
There,
ones that you've listed as well. Give me one
okay.
that you don't parrot me what I've said. I want you to think on this.
Okay. Culture-wise, is something I mentioned, right? Making it available in Europe, from an ads standpoint, we could possibly promote more things that is more popular in Germany. For example, beer. That's kind of a stereotype,
Okay.
but that's
Okay. I'm gonna stop. Okay, so
yeah,
let's consider location, right? Location
yeah,
changes, right? So what changes with those locations? Ads. Isn't
yeah,
the ads you're gonna show different?
yeah. That's
You see how like those changes causes a change in the product? And another one,
yes,
like you said, you kind of touched on it. It's like, oh well, we need to change the privacy. We need to change the privacy, right? So that's going to change how we
yeah,
store things. So how does our database change in order to be GDPR compliant? That's what it's called, by the way, and it was a huge pain in the ass. But but yeah, like you touched on it, like, oh, we need to be in compliance with these laws. We can't show certain kind of content to like under 13-year-olds or whatever, right?
yeah,
We need, like, what might be
yeah.
18 and under on Facebook in the United
Okay,
States might be 13 and
and
under in over in Europe. So how do we handle that data?
okay, and also I guess I would also mention like how long we want to store certain data.
Sure.
Because certain countries may not want us to store user data for more than 2 years.
Mm-hmm.
And also like we also need to start handling internal like privacy in terms
Mm-hmm.
of like who can see a certain user's data and how those permissions
Mm-hmm.
should be configured.
Mm-hmm.
Because certain laws may require that, not so that like not everyone in the company can simply like look at all consumers user data.
Mm-hmm.
So we obviously need to also start recording like internal users or like employees like
Sure.
privacy stuff like that.
Okay. Okay. Fine.
But yeah.
You're talking about things that are like, oh, this is like peanuts compared to the core
Okay.
product. Like again, it's like you did you're handling data fine, but you're still kind of in that mode. You're still kind of like, what's it called? You're still kind of like focused and tunnel vigiling into just one area. It's like, oh, I hit this handling data. What else can I mine from this handling data? I want you to be more flexible, more adaptive. A look at how different companies handle the change. I want you to start reading these engineering blog posts and these news articles. Like you see me read Hacker News at the beginning of every single stream, right? There's a reason I do that. It's because I want to know how different companies handle different things and how that reflects on engineering. And you should probably start doing that too, especially if you want to be a very good engineer and start thinking about like the products that you're writing. Like, and in fact, it's component responsibility. It's just a subset of all that. It's like, okay, well, maybe we need like one component to write to one database that is only going to be used in Europe. And then we need another component that will write to the United States. Because maybe we need to store data differently on these continents, or maybe this component just filters data. We still have the data, but then we filter it and display it to the users just so we can get around legal laws, and just tell the US, hey, we're GDPR compliant or whatever. The point here is to really be more creative and understand the problems that these companies are running into, these products run into, because there's always going to be problems. The thing, what you're doing is like, you're saying, hey, give me the answer and I'll mine more of the answer. We're not looking for that. We're looking for all the different ways things can go wrong. It's knowing this, and that's what's going to help you in this interview. Does that make sense?
Yeah, but yeah, it makes sense. It's just that I still struggle with like thinking big, if that makes sense. Like I still struggle with like seeing these as quickly as I should be in an interview. Like probably if given like a lot of time, I could probably like come up with more of these stuff that you talk about, but obviously I don't come up with them like quick enough.
Or the easier thing is, you have coworkers. Why don't you ask them about like the challenges they face when writing their products? Treat them up. Just have lunch with them. Have 40 minutes with them. Ask them, hey, I noticed you guys wrote this product. What were the considerations? How did you handle this problem? How did you handle that problem? Or what were the problems that you were running into?
Okay.
Seems like a pretty good idea. I don't know. What do you think?
Yeah. Yeah, I could probably start asking some coworkers that I'm closer to.
Yeah. I think it's like a lot of this comes down to the experience that you have. And I'm going to try tailoring this. Like, give me a better sense of like what you do, like on a day-to-day basis. And I'll give you some recommendations. And then to close this out, we will do like a basic problem together.
Okay. Day to day, like I think that's the other thing I also struggle to like summarize, but and I guess I would give you like like context of like what my team does, because my team is kind of in it's called core products under the commerce engineering department.
Okay.
We mainly handle the integration between different services and vendors, because we control let's say this. We own a lot of the components that are responsible for the integrations between Facebook data and like external ERP or like external vendors or external logistic partners that help us deliver and ship products. And also like, the product management system. And we also responsible for the components that do the entire order fulfillment process. I mean, we don't handle the website, but like when an order comes in, we are responsible for making sure like we have shipments created and it's delivered to the customer, or like all those kind of stuff. So basically order management, inventory management, stuff like that.
Okay.
And my responsibilities include like, right now I'm owning the project to complete the integration for a point of sale solution provider, meaning this is mainly for a retail store, and I'm leading that project because the previous senior engineer kind of left the team and I had the most context. So now it's kind of on me to design that.
I get it now.
Okay.
So you're basically saying, hey, how does our internal services communicate with external services?
Yeah.
That's pretty normal. That's actually very similar to like what I've seen in like say let me give you a solid example. Uber has a partnership with Barclays, right? So one part of it is like, hey, we have an Uber credit card. How many points does this person have? Well, Uber doesn't know, but Barclays knows. How do we get all that data and save it and make sure that we can redeem those points? It's pretty similar to what you're doing, really.
Yeah.
So now that you know that, like what external partners we work with and what external partners that you guys work with, so you have a good understanding of like what changes in the inside of Facebook affect how you communicate with your external partners. And so doesn't that affect how you might design a product For instance, if your product says, hey, we assume that this vendor is for life, well, how do you deal with multiple other vendors? Maybe you might want to think about your product actually being handled like for instance, let's say that you hook into, I don't know, American Express for like payment processing or something.
Yeah.
Well, maybe you might consider, hey, well, tomorrow, what if American Express goes under? We're totally fucked if our product just completely relies on American Express. Maybe we want to have another, payment process like Visa. Maybe we want to have our product accommodate for all these different, like credit companies, right? And the point I'm trying to make here is that even in your position, you can still think about the exact same questions.
Yeah, so I do think about questions like these when I like do like my work. For example, like I also have to design like the process that syncs product information and inventory information between Facebook and the external vendor, right?
Okay.
And so I'm also like, when I'm writing these components, I'm also thinking like, okay, how do I write these components in a way that such that tomorrow, if we want to partner with a new vendor in, say, Europe or a different country or even a different city, I can easily integrate that vendor into the existing components. That means I have to write the components in a more generic way, such that I could like onboard and add or even remove existing vendors as I need to. And logging components, metrics, they should all kind of be based on like the same centralized or like the same common characteristics. And then maybe certain vendors will have like an extra like components, like one or two, to do some extra like filtering and stuff like that. But in general, I want it to be more generic so that I could like scale it as we add and remove vendors. Or even like if say one day we don't want to add more vendors and we want to do everything ourselves, we could use this to like integrate with internal services.
I get it.
But when I guess like with system design questions, like because then those are not things that I deal with, or like these like, because like when I'm working on my job, like I have a lot of context, so it's a lot easier for me to kind of come up with these different scenarios. But also like when in a system design interview, like because I don't have much experience, I'm pretty slow and I kind of struggle with like coming up with these stuff.
Okay, sure, fair, but it's fair if it's like experience. But in theory, you should have that experience if you are working with a point of, especially if you're point of sales and you're dealing with external vendors. It really is like important. It's not like, I would say, read some of the engineering review documents, look in the meetings, and just like say, hey, yeah, what are the thoughts we're considering? What are the points? What are the objections people are bringing up in the long-term architecture? Because it's not about like the code, It's about architecture. Because I mean, yeah, you might think, oh, well, let me just go ahead and use an interface instead to code this up. But really, again, like I've said before, it's the same idea. Code is meant to drive an idea. So in this case, your architecture should be meant to say, oh, these interfaces that we're using are meant to represent the uses for a bunch of different external vendors that might be interchangeable. Like maybe we ship something to Shopify, but then tomorrow we ship to, I don't know what else is out there for e-commerce. Yeah. But you get my point. Is that these patterns that we're using, this code that we're writing, is meant to represent an idea. It's meant to represent some idea that we have, and it's meant to change with the concerns that we have. So with that in mind, I'm going to give you a problem. So, and I want you to like spend some time to really I don't expect you to finish it. We only have like 20 minutes left, but I want you to really try focusing on this first part, the exploration, and maybe like some other, like scoping the problem, what might change. And I really want you to focus on like what might change for this. So for exploration. Okay. So let's suppose that I have, okay. So let's say like Tinder, right?
Okay.
And I would say we've currently captured the U.S. market, right?
Okay.
And now we want to try to upsell them on memberships. How might we do that?
Okay, by capturing on the U.S. market, you mean we have like a decent base of users in the U.S., right?
Yep. Let's say that we have a U.S. market. We have had a very good stronghold. It's hard for us to acquire more users, but right now we need to milk the existing users for all their money. So we want to be able to upsell them on memberships. We want to go with memberships. Let's say, suppose our memberships are product, or like memberships, subscriptions, or whatever. How might we handle this? What might change? I want you to do the exploration step of this.
Okay.
And how can our product handle this?
I'm just gonna like think out loud and kind of like list of the things that I think of right now. So
Yes.
I feel like we want to know like um what do the users crave, or
Okay.
like what are the user patterns like. So obviously we would need like maybe data or like some stats that we can look at,
Okay.
analyze, so to see like what they crave, and we if we could provide that, or like kind of milk that, we
Okay.
could use that as a feature. So like obviously like, we also want to think about what a membership or subscription entails,
Uh-huh.
meaning what features we provide.
Mm-hmm.
So obviously, like if we think about like what Tinder currently does, obviously membership, we could probably say something like unlimited swipes.
Sure.
Now, building onto this, the other thing is that in the future, say like this could be a problem if like more and more users kind of like end up swiping until like there's no more swiping. What if we, instead of like doing unlimited, we go from the original of like 50 to just like 200 instead of
Sure.
unlimited. That way we still keep like the amount coming.
Okay.
So besides swipes, we could also probably do something like based on what Tinder has. We could also offer like more. I'd say, how do you say it? More quota for super lights, and in this case, we also need to make super lights more attractive, meaning we kind of need to let the users know that this gives them a higher chance of like striking a conversation or anything. So like definitely the key thing is the two main things I'm seeing is that we need to know like what users are craving, and
Yep.
kind of offer that in the membership slash
Sure, but
subscription.
that's tautological. It's like, of course, we want to service what users
Yeah.
want. My question to you is: out of you already know like some of the basic features of Twitter, like super like
Yeah.
and unlimited swipes.
Yeah.
How does that affect
Yeah.
your product? Let me ask you that. And how are you going to write this?
So okay, in terms of how it affects the product, is that now we need to capture a user's how do you say privilege or status.
Okay.
So previously we may not have like all users may be the same, right? But right now, if we have members and subscriptions, then we need to capture like its current privileges.
Okay.
And this includes like end time, the subscriptions and memberships. Yeah, and this I guess like this also comes with like I guess changes in entities. So mainly if we talk about user, because I assume that's going to be the main thing we talk about here. We obviously need privilege, end time. We now need to capture payments as well. So we potentially may need to have payment services. We previously may have been free, right? Now that if we offer membership subscription, we need to do payments. Product wise, what else changes? Let's see. Okay, I guess I don't know if this is worth mentioning, but like maybe UI would need to improve
Sure, why not?
to make memberships or subscriptions more tempting. This may be outside of Tinder itself, but we potentially need more ads to promote the new memberships subs.
Sure. Thanks to Mom
Outside
for
of
that shit.
yeah. Let's see.
Okay. I think you have enough.
Yeah.
This is like a good
Yeah.
exercise in like scoping out like what might need to change and what you need to handle.
Yeah.
So I think
Yeah.
this is pretty decent. What I especially liked here was this one. Because let's think about this. The subscription is
Yeah.
mostly going to change how a user interacts with the app,
Yeah.
right? I mean, that's the same
Yeah.
thing with internationalization, except like compared to internationalization. Internationalization is more about adopting to what already exists, right? Like with the laws, with the culture, and
Yeah.
trying to integrate that with the app. Here, we're offering users new features on top of the existing ones, and so you've done a good job of identifying that delta. Like, okay, well, we need to have we need to add payment services if we were previously free. We need to know like if these subscriptions are privileged. I think what would have been worth asking is, are these privileges tiered? Are we gonna have multiple subscriptions? Is a subscription for unlimited swipes gonna be different from the ones with unlimited likes? And if these like or can I buy these as like tokens? You know, it's like there's different types of subscriptions. Is also something that you might want to dive deeper into.
Okay.
You know, like, do you play like Fate Go or like or Genshin Impact?
No, but I was on Tinder, so I do know they have different tiers.
Yeah. So the point here is that there's many different ways of monetizing your users like this, and the question is, well, can you actually adjust your product? Can you ask the right questions in order to like accommodate for those? Because without the proper scope, you don't actually arrive at the proper product. So let's go with this. Let's say you've scoped this out. How might your product actually change? What are the technical considerations now?
Okay. Obviously, data model changes.
Okay.
And components now need to integrate with payment service providers, assuming that we integrate with external payment service providers. Let's see what else. So because of data model changes, this potentially means we need to either refactor, rewrite, and plus new components to kind of handle these privileges and time.
So how would these privileges really work in this data model change? What you're saying the change, but how they change?
Okay. So say previously user may have like I'm just gonna go pretty simple, but we have like name, location, name, location, and we obviously have like metadata like created time, that's motivated time.
Sure.
Let's see, profile, I guess pictures. Okay, these are probably going to be the main things. Profile, it's like profile. We can say this includes like description and stuff. So in terms of like data model, we would now include like privilege. This could be an enum that includes different tiers.
Okay.
So it could be like golden, silver, or like 1, 2, 3, depending on like the privilege. And now we have an optional of like payment info.
Okay. I'm gonna stop you there. So the thing is that kind of, you see here like how you're kind of tied into tiers now.
Yeah.
Remember what I said before about like the different types of subscriptions? This might actually change, because like think of it this way.
Okay.
What if tomorrow Tinder decided to say, hey, well, instead of having tiered subscriptions, why don't we make all these different things separate? Do you understand where this might fuck you?
We would now then need to kind of basically handle everything that touches this.
Yeah, exactly. So it's like if you don't ask the right questions, if you don't scope the right thing at the beginning, or try to figure out if your tiers or these subscriptions independent of one another, then this kind of fucks your data model.
Okay, so when you told me to now like think about like the actual technical changes.
Yes.
Instead of like going here, you're saying that I should have been asking like, okay, are we going to stick to tiers, or is it like possible that we would switch to a different subscription or payments model?
Correct. Remember what I said before about change. The change is constant. So the question is, can you anticipate the reasonable changes? That's the question you should have asked in here. And based on these reasonable changes, then that's going to affect like your how your model actually represents this.
Okay.
Do you think it's let me ask you? Do you think it's reasonable that Tinder would change it from a tier subscription to a individual subscriptions or tokens?
Yeah, it's reasonable, and like the other way I can see this too is like you can even buy tokens and kind of give it to other people, kind of like gift cards.
Sure. Yeah. You see how like all these are basically different ways of thinking about the exact same problem. It's like it's just understanding what is going to happen on the horizon, and then how does that affect like what you actually do for the coding for like this design. So you see like how missing just a simple change like that actually ends up creating a lot of issues.
Yeah.
So yeah. All right. So I want you to continue on this line. I want you to actually talk about like component responsibility. How might things change or how might your entire system changes?
Okay. So the main feature of Tinder, or two main things of the application are going to be the actual feed where you're swiping, and the actual chatting conversation part.
Sure.
And I guess from the chatting or conversation part, assuming that we don't limit the number of messages a user can send, there won't be much changes there.
Sure.
The main changes is going to be on the feed part.
Okay.
And I guess now, like, all the components at any given time have to be aware of the user's status, meaning like the user could have like certain amount of tokens, or like a certain tier of subscription. So all components need to be aware of that status, as well as the quota left for that user. So it could be number of swipes, could be number of super likes.
Okay.
As well as
yeah,
the
so
ability.
that's like, that's a statement of fact. Yeah, of course they need to be aware. But
Yeah.
then how does that affect how data flows in your system? And what are the changes you're going to need in your system?
Basically keeping track of the quota, or like the ability to make a payment and immediately change.
You're not understanding it. You're not understanding. Let me make this simple.
Yeah. Okay.
So in Tinder, let's say you receive a list of people, right? And then you swipe, right? And then you send all your likes to the server, or likes or dislikes, whatever. Dislikes the server. The server sees if they are a match, or you know what? Actually, it could be like list of people, and then inside that could be like, did they like you, as well. So that way you get like the instant notification, like the instant match. Like, because when you swipe, you don't actually wait for them to say, oh, it's a match. It's like, did they like you, and then that sort of thing. And so then you send all your likes and dislikes to the server, and then the server will process these, right? Process these, and then update the graph between users. Because if they liked each other, then you update the state. This is like a theoretical example of how it might work. And so, what changes in this process? Now that you have to deal with the super likes and the subscriptions, what changes in this flow?
Okay, so one thing is for Superlight, in the list given by the server, actually wait. So we receive a list of people from the server, right? And in the case of a Superlight, we need to show them first, if that makes sense.
Okay.
So we can either kind of always keep the Superlights in the front of the list, or we could just have a separate list. So it could be like receive a list of people who Superlight / like you. And for the list of Superlight, we obviously want to display in a different way because those are Superlights. And in terms of like sending your likes and dislikes, now we also have the ability to send Superlight as well. And I guess like previously, when quota is up, basically application will force user to wait. But now we can also offer them to pay and kind of become like a privileged user to allow them to send more likes and dislikes. In terms of like server, like the backend processing, likes and dislikes still like super likes will still count as a like. It's just that the way we send it to the user will be different. So in terms of like the relationships between users will not be different. Let's see. What else?
Okay, so I'm gonna pause here. We have 5 minutes left because I want to go over your schedule and assign you stuff. But basically, I think you're like, I want you to be able to do this exercise. So finish the Tinder exercise with feedback from the the interviewers and what I said. So I really want you to think about like, okay, well, if we make these changes, why are these changes? Why did I make the change that I did? Is it reasonable? Can it handle future changes? I really want you to focus on these questions when you do system design practice like this. So it goes to this exercise of like, look at the past, like look at freaking features, look at and products that have grown throughout the years, and try to see if you can predict how they managed to scale things or make new product changes. And ask yourself, is this reasonable? Can this actually accommodate for the future changes that we see today? And try to track that change, because the reason why I say this is because you're still middling around like, oh, well, we need to have a separate list of super like users and users who like you. Why does that have to be separate? Why can't they just be like different states of the same model in the list? So it could be like a person, super like field 1, and then like 1 or something like that, because super like is just inherited from like. Because if they liked you, they super liked you. I mean, if they super liked you, they liked you, and then also on top of that, like, how does it change the database as well? Because you see like all these different component responsibilities. What is the assumed flow? How does that assumed flow change? It's like looking at that's gonna be the bigger one as well. Like, well, now I sent you like a this is like the assumed naive way of doing these things. Well, what components in here are going to change? For instance, now instead of just processing them, what does this process now entail? This process now entails, oh well, if someone taps super like, but they are not, what's it called? They don't have a valid subscription. Who do we send? What we need to process that, right? We need to process that subscription. And if they didn't have that, do we want to send back a response saying, "Hey, upsell you on the super like"? You see, like how I'm basically just going through how the user interacts with these things. Because this is fundamentally like what the driving motivation is. Like, and that's the core of every single product. Your own user, not you, not the technology, the user. And you want to see like how the user impacts the technology, impacts how you write things and how you organize things. And I really want you to like keep this in mind, because the way I see you writing right now is basically you're just like expecting someone to give you a problem and then you just write the implementation for it. I want you to think bigger than that. I want you to think about like what can change. Think of yourself as the master. Think of yourself as the project lead. Think of yourself as the architect. You are the architect. So, okay. You need to handle everything that's happening today and tomorrow. Okay.
Okay. By finishing the exercise, how far do you mean? I'm not quite sure. Like, what do you mean by finishing?
I want you to do it to the same extent that you did the practice problems, like with the like with your coworkers.
So meaning I would also think about like the actual databases, stuff like that, like the actual class, like a classic system design.
Yeah, think of it like a product system design that your coworkers gave you. I want you to think in terms of that, and I want you to write it out and then show it to the same coworker. Get his response. I mean this because the reason why is because the people who are going to give you the best the best feedback are going to be people who think differently than you. Like, I can tell you like what to do over and over and over again, but if you have someone else out there who can give you a second opinion, that's also going to be very, very helpful. And say, hey, I did this exercise. What do you think? And then he'll probably poke holes at you. It's like, hey, well, you need to think about this, X, Y, Z. How are you going to handle this? Did you think about this?
Okay.
So I want you, and like, there's a second reason I'm doing this is because I'm sure you don't want to lose face in front of your coworker, right? So you better not give him some freaking garbage. So you better like try to do this as much as as well and as thorough as possible.
Okay.
So that's your homework. I want you to do this and I want you to do it on before Thursday or before a replay analysis, and I want you to give me the feedback and we can go over it as well.
Okay. I'll try my best to see if I can get anyone to do it. But I can guarantee that they have time to meet up to do this.
No, it's just just show them the sheet. Show them like how you did it. Like he wrote the feedback, right? I want you to do a similar summary. And you send over email like, hey, can you spend a minute or two looking at this?
Okay.
And then if they want to give you more thorough feedback, welcome it. Okay. As far as your study goes, I'm gonna say repeat what we did before. So let me go ahead and show you the study plan. Oops. Okay. got it. Okay, so this starts. So same thing. I wrote the red flags above. Greedy, do recursion and greedy. So you're gonna do recursion and greedy on EPI.
Okay.
And then I really want you to do the reverse engineering thing as well. Like really focus on that. I know you're just kind of splitting your time and you're getting your feet wet, but we're not gonna. Well, I'm gonna gear you more towards the product design stuff. We're not gonna cover a lot of the DDIA stuff because it's not necessary. Because like me talking about leaderless selection is not gonna help you.
Okay. Sure. Makes sense.
But it's still cool to like look at DDIA and kind of see. Oh yeah, this is kind of like how things work underneath the hood.
Okay.
Keep these in the back of your mind. Yeah, but that's it. I still want you to focus more on the algorithm portion. It doesn't matter if you smash the system design portion if you just fuck up the algorithm and go full Pepega.
Okay, for sure.
Okay, and I really mean it. I need you to do the reverse engineering. You fucking skip on this shit again, we're gonna have a real problem.
Okay. I'll definitely work on that one.
Okay. Are there any final thoughts?
No, I'm just like thinking about the Tinder exercise,
Yeah.
but yeah.
Yeah.
Yeah. Thanks, Edbert.
Yeah, and read some blogs, read Hacker News, read how these products and things evolve. You might get a much better perspective.
Do you have any like recommendations in terms of blogs, or should I just stick to Hacker News for
Any
now?
engineering blog, really, like Uber engineering blog, Robinhood, like yeah,
Okay.
like the fucking understand the fucking infinite money glitch. Like that,
Okay.
keep that in mind. Yeah, actually, the infinite money glitch. That is what happens when you design your products incorrectly. Alright, got it?
Okay. Yeah. Got it.
All right, sounds good. I'll talk to you later then.
All right. Thank you. Bye.
Bye-bye. All right, I'll answer some questions in the chat now. Let's take a look. I think I'm Sarah actually made a pretty good blurb here. Business courses. If you think managers sit there only thinking about engineering, you're wrong. Most of these people are thinking about your end product. You think too low level. If you want to know why a decision you hate is made at work, as an engineer, it might not make sense to you. Your teammates are all complaining. Most of the time, the answer is in a business decision. Yeah. Managers are thinking business and how this product will be viewed, perceived, and the laws that affect it and so on, especially past the staff engineering level. Absolutely. Most engineers don't want to acknowledge this. The sooner you think of both sides of the table, and believe me, there's no fanfare around products that don't make money. The better off you'll be. Yeah, that's pretty much correct when it comes to product. Although I would say that most product engineers actually do have the thoughts of the end user in mind, especially at companies where the architecture is well defined. So places like Uber, Facebook, Google, where your architecture is already set up for you, all that's really left is for you to make money off the user. And so really, I think this naturally attracts people who can think in a business sense as well. And that's really what I think the product interview is actually geared towards. It's like, and you need to really think about how the end user interacts with your own product. So very much so, you really do need to have this sense of like how your product can change in response to users. So let's see. Hey Edbert, is Blind 75 leak code good? I mean, I would say it's decent. I would say it's like a good as a spot check. And it definitely has higher quality problems than most of leak code. But I would also say that if you can't help it, just do Elements of Programming interview. That book is so fucking boss, man. Like, and there's nothing else like it. It's got more consistent answers. It's got really compact answers, and it really does its best to explain like these answers really well to you. And that's why I really press on this guy to say, hey, do the reverse engineering. Try to figure out how Elements of Programming interview came up with their answers. Like, I think it's the gold standard. Blah blah blah. System design is not important. No, I'm saying that if you fail the leak code portion, the algorithm portion, like completely, and you pass the system design, at his level, it's like they're probably not gonna let him go with that. They're gonna probably just straight up fail him. It's like, hey, well, system design's not as important. We're trying to hire you for the L3, L4 level, so you better do good in at least the algorithm portion. When it comes to like senior level and above, you only really get one algorithm question, and then the rest is like system design stuff. So that's where the balance ends up becoming more towards system design. And he's not at that level yet. So that's why I'm saying that it doesn't matter if he doesn't do super hyper well on the system design. What matters at his level is the algorithm portion. And so if he fucks up the algorithm portion, it doesn't matter how well he does on the system design. I don't think most companies or people think like that. Hey, this guy knows how to design a system, but he doesn't know what a hash map is. I have never met anyone who is hired like that. So, anyway, let's see what other questions were missed. Yeah. I like my social credit memes, man. You know? I don't suffer fools. Yep, you're right. I don't give a shit. Our goal here is to make sure he gets the offer. Right now, we have a target date of 11/14. And so a lot of what's going to happen at that day is going to be based on, like, what he does this week. Like, I know, like, it's like, oh, 1 week before. But really, it's like a culmination of all these different things. I want him to... I noticed that during this session, I was repeating a lot of things that we talked about, like, maybe 3-4 weeks ago. And he kind of probably forgot. But I think that if I make him reverse engineer elements of programming interview and keep the lessons in mind, I think he will do much better. So I'm doing fingers crossed. We have only 3 shots at this. But I know that I can at least get him 1. Ideally, I'd like to get him 2 or 3. So we're aiming for that. I'll be pretty disappointed in myself if I don't at least get 1. Which design is important, LLD or HLD? I actually don't know. I actually don't know what those are. High-level design or low-level design? Oh, I see. High-level design is more associated with products. You know, this is like the services, the ingestion engine, how you communicate with outside like services, like you know, the American Express example I gave him. And low-level design is going to be like your load balancers, your MySQL databases, and everything in between. And so for me, I see this as just another level underneath. And if you actually care about like what you're writing and what you're working with, then naturally both of these are going to come to you. Of course, you're going to most likely work on a high-level design on a day-to-day basis. But the what's it called? The interview that he's elected to mock with is all high-level design. And so, fortunately for me, I've had the pleasure of actually being able to see how high and low level design stuff actually works. And so I would say I'm pretty okay with doing mock interviews and giving feedback on both, actually. So I wouldn't say one is more important than the other, but I take that back. If you're, in general, the tried and true is going to be the low-level design, right? But, because that's pretty standard. Facebook is the only one I know that does a very specific product design. And, you know, Uber does some to an extent. But no, I take that back. Facebook and Uber definitely do. I think maybe the industry is kind of trending for that. But I still think low-level design is still some fundamental stuff that people really need to understand as well. But yeah, I guess like my opinion, if you had to put me on the spot, is going to be get the high-level design and really understand the changes that affect your product. Then go to the low-level design and then really understand how like the product changes affect your low-level components. How would you what? How long would anyone need for system design? Is that the question? How long does someone need to study system design? I think if you're doing it right, you only need like 6 to 8 weeks. So I had a client. His name is Valid, and he is actually in the Discord. Feel free to ping him. I started him from nothing. I mean zilch. Like he was like L3 engineer at Goldman Sachs, 4 years of experience. We started from nothing. In 6 weeks, I got him. Actually, I worked with him 3 months, and we only focused on system design for 6 weeks, right? And so in the 8 to 10 weeks, I would say 8 to 12 weeks that we were working together, he went from L3 to getting 3 L5 offers: NerdWallet, Tesla, and Box. So, based on what I've seen from him and Pavlo, who got a L6 offer from Wayfair, it only takes 6 weeks of really quality work to get there. Of course, without knowing where you're going, it's gonna suck and you're gonna take much longer. But if you can do it the right way, then you're gonna get there in a very quick amount of time. So 6 weeks is plenty amount of time. You have 3 to 4 years of experience. Where should you study? System design interviews. Yeah, so I would say it depends on what type of interview you're doing. But to study for this, I would say grokking the system design interview, and then they had a follow-up called diving deeper or something like that. And then read DDIA. I think a combination of those 3 are going to do you some good. But also read engineering blogs on a daily basis. Really understand how these products are written. I think that's also the best one. I haven't met a product design blog, or no product design course yet that I think is worth anything. I actually don't even know if it exists. What is this, from personal coaching with Edbert? Yeah, pretty much. I worked with him for 3 months, man. But I'll drop his... If you tag Valid in the... But yeah, I dropped his name, his user handle in the Discord, in the chat. So feel free to ping him. But I have a interview that I filmed with him over the weekend, and I will upload that later on. But I would highly recommend that you guys watch the other interview I did with Pablo on my channel as well. This was a live stream that we did, like, I would say, like 2 months ago or something like that. Here, let me find it for you guys. I'll drop it in the chat. But basically, he is like, he basically did pretty much he went through the same process as Lee did, but I think he was much more rigorous and harder on himself, actually. So let me link that to you. He put in a lot more effort outside of the interview, actually. And I think one of the surprising things I learned from the chat is that Valid only spent like 15 hours a week. I'm not even joking, like 15 freaking hours or some shit. It kind of boggled my mind. That actually kind of boggled my mind how he was like able to do that. Even I don't think I could do that on 15 hours. Yeah. So I would say for each side, at the worst case scenario, 6 weeks for algorithm, 6 weeks for system design, if you're starting from zero. But the fact of the matter is that most people are starting from zero or effectively zero, because I spend a lot of times just trying to break bad habits. That's really what a lot of the stuff boils down to, so. I guess this, actually, the funny thing is that this stream has been, like, I think one of the more popular ones. I think I've only gotten, like, 3 or 4 viewers, like, for the past 2-3 weeks, actually. It's kind of, like, crazy, now that I think about it. It's, like, I've been streaming, like, for a good 3 months now, and I very rarely break more than 10 viewers. So, it's kind of funny, like, yeah, I'm actually super grateful that more than 10 people showed up to spend the night with me, man. Like, it's pretty nice. Thank you for watching, guys. Keep in mind that I do this weekly, Monday, Tuesday, Thursday, and I guess Friday now. Monday and Tuesday, we do the coaching sessions. And then Thursday, Friday, like, we do the replay analysis, actually. And so the replay analysis, for those who don't know, is I make a client really record themselves doing a problem and then record themselves actually reflecting back on that problem. And I pick apart their thinking, their approach, and everything, like, hey, why did you think this? Why did you do this? Here's what you might have missed in the replay. Here's what you might have missed when thinking back on things. And really, I really emphasize this replay and self-evaluation because I think a lot of people really gloss over it. You can see here today, like, if you compare, like, what he did last week versus what he did this week, there's very little change. And so that's why I was, like, really hard on him, because he didn't do the self-evaluation, and that kind of showed in his performance. If you, like, self-critique, and you have someone else out there to help you guide you, you're going to make progress. And it will show on a week-to-week basis. That's why we do the bi-weekly check-ins with the coaching sessions, the replay analysis, and then I do a 15-minute call with them as well, just to make sure that they are, A-okay and they're still on track. So you can watch, like, all the past interviews as well, and the past live streams to track his progress. You can see, like, how, like, this shit's real, guys. Like, you can see how he started off on week 1 until we're at week 4 right now. And you can watch those coaching sessions as, like, a replay for, like, yourself as well to know what you need to do. And I think that it's going to give you a very good perspective on, like, what you can do to improve your own interview performance. And the stuff I talk about here is not just for coding interviews. It's how to become a better engineer in general. So I think that a lot of the stuff that... So it's the way I see it is that this isn't just an investment in, like, solving coding interview problems. It's an investment in your own career. And these are the people I really want to work with, the people who really are passionate about this and really want to work hard. And if they work hard at just this and understand what I'm trying to do and they see the results, I think later on down the road, they'll be super grateful for having gone through this whole process. In fact, like, I really want to check in with, like, Valid and Pablo, like, 1 year from now, see how they're doing in their career and, like, get their perspective as well. But the point here is that when you're getting coached by me, it's not just about, like, becoming a leak code machine. It's about becoming a better engineer overall. So that's kind of like my offer here. What's a bad habit to avoid while learning algorithms? Doing it mindlessly. Seriously, like, one bad habit I see is, like, people throwing random shit at the leak code compiler and thinking it's gonna, like, freaking compile, like, and it's like, oh, well, it didn't work. Let me go ahead and let me try this, and they don't actually think about the problem that they're solving. And so they might have solved 400, 500 leak code problems, but all they did was, like, solve the problem without actually thinking about how to solve a problem. They just, like, threw freaking like code garbage at a compiler and then solved the problem and then moved on. They learned nothing. That's the big mistake I think most people have. You get riled up. Nah, I mean, I just like being myself, man. I don't try to sugarcoat anything, and I think it's good for my clients as well. Like, I'm not trying to impress anyone. I'm not trying to like, oh, I need to obey like Susan, whatever her name is, YouTube CEO. I don't care about that. All I only care about is like the client's results, because my ego is invested in that. I believe I can get them any offer in the world. I better freaking deliver, you know? And if I don't do that, then I'm starting to think to myself, what did I do wrong? It's like, I'm the one responsible for all this shit, right? Like, they're trusting me to get them results. And so if they don't get the results, it's my fault. That's the way I feel about it. And so I take this shit personally. So whatever it takes to get the results, that's what I'm going to do. You're gonna tell some folks on other channels. Yeah, people just don't know. Yeah. In the future, will you make study videos? I think I've made a few already, actually. Just go through my channel. I've made a guide on, like, welcome to the coding interview, you suck. That is just basically the guide on how to actually handle the coding interview. And I have a guide. Yeah, seriously, I have my freaking guide. Hold on, let me link it. Here's the guide, and then the whole playlist, actually. Yeah, let me link to the playlist. Here's the playlist, and then like you can look at a bunch of other different. Hold on, and then let me link you the. Actually, I should add these to the playlist as well. Yeah, look for any of the videos where I tag with mistake evaluation. So let me give you an example. Yeah. And then yeah. So like here, let me link these. So for instance, let me. Hey guys, it's Ed. Oh god, that's loud as fuck. Yeah. This one right here. Like this is how I study, and like you can see here, I'm gonna mute this, but you can see here that basically I treat a lot of these clients' like mistakes. I go through like their solutions, and then I just show you how I think about it and how I would self-evaluate. And here, like I also make them keep a practice diary. So you can see here, like yeah, like once I've diffed all the performance results, I then actually record them in a diary here. And I think this is pretty standard, actually, for any single client that I do. Man, the video actually cut this out, shit. But yeah. This is like a sample diary of where I actually put the problem sheets, and then I put the like the notes on it. So I mean, this is part of it, but like I think I have a sample study sheet in the guide as well. So you can see here, like I actually keep my notes in here. And then like here's the problem sheet I use. So yeah, for sure, man. I guess people are like jumping off the stream, so I'll answer this last question and then I'll jump out. What do you think about expanding solutions vocabulary? My SCH curriculum, your school curriculum leaves much to be desired, and I do want to get good at LeetCode questions. Let's start with memorization. Yeah, copying is, you know, everyone starts off by imitating, and everyone starts off by copying. But then after that, you realize it's not enough. So then you gotta, you know, think like an engineer. Think about like how you can solve problems faster. What techniques allow you to solve problems faster? And if you go through like my past videos, you'll see that I constantly pose this question to everyone. And so, yeah, I think rote memorization does help at the beginning, but then you need to really start going off on your own because there's like thousands of problems out there. You can't memorize all of them. But yeah, like I said, that was the last question. I'm going to sign off for tonight. Thank you everyone for watching. We will have another stream tomorrow, 8 p.m. Pacific Standard Time. And then Thursday, 9 p.m. Pacific Standard Time. And then Friday, 9 p.m. Pacific Standard Time. So hopefully you join me for that. Thank you all for watching, and good night.